Okay. Table below gives values of a continuous function. Use a midpoint Riemann sum to estimate the average value of f from the closed interval 20 to 50. We've already said that if we're going to use a midpoint Riemann sum, we're going to have to use 3 subintervals so that we have a midpoint for each of those intervals. If we use 2 subintervals, we would have 2 midpoints, not 1. We wouldn't know what the midpoint of the midpoints were. And if we used, what, 1, 2, 3, well, that won't even work anyway. So really, there's only one way we could set this up. So the average value of f is equal to 1 over b, 50, minus a, 20, times the integral from 20 to 50, f of x dx. So we have 1 over 30, and then it told us to approximate this by using a midpoint Riemann sum. So my first interval from 20 to 30 has a width of 10 and a midpoint height of 38. My next interval from 30 to 40 also has a width of 10 and a height of 29. I'm using the midpoint. My last subinterval, width of 10, height of 48. Now, if I had to do this by hand, I would factor the 10 out. I know you guys had your calculator, but if you didn't have the calculator, that would be the easiest way to do it there, right? So I have 1/3 times 115, if I added those together, right? Yeah, 16 and 9, carry the 2. It's 115 divided by 3. If it is a calculator problem, a decimal would also be acceptable as long as it's correct to 3 decimal places. That would be, what, 38.333 would also be acceptable if it's a calculator problem. The continuous sign, what do you mean? Oh, you mean the bar? Because who cares after 3 decimal places? At a certain point, the level of accuracy is so precise that it's insignificant. You can do that. It's not wrong. All right, any questions about number 7? Number 9, they want us to find the average temperature from 9 a.m. to 9 p.m. So we were discussing that if little t is measuring the hours after 9 a.m., the 9 a.m. is t equals 0, and 9 p.m. would be t equals 12 hours after 9 a.m. So then the average temperature, T average, it's the average value of T. Yes, you're finding at what function value here between 0 and 12 do you find the same as the area under that graph? But here we're actually looking at it in context to a situation. This is representing temperature. What was the average temperature during that 12-hour interval? Which is 1 over 12 minus 0 times the integral from 0 to 12 of our temperature function, 50 plus 14 sine of pi t divided by 12 dt. We can use our calculator to evaluate that. With respect to t from 0 to 12. Oh, an approximation here. So we have 1/12 times 706.952. So if I take that and divide it by 12, I get that the average temperature was 58.913, if I round, degrees Fahrenheit. Any questions about that one? Okay.